Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today our topic is about double angle formulas. As you know, we have studied in our previous lessons some indifference formulas, which were sine x plus minus y, cosine x plus minus y, tangent x plus minus y, cotangent x plus minus y. In this section, we will consider a special case, which is x equal to y, and we will find the formulas for trigonometric ratios sine 2x, for cosine 2x, for tangent 2x, and for cotangent 2x. The first formula is sine 2x. As you know that the sum formula for sine function is sine x plus y equal to sine x cosine y plus cosine x sine y. If x is equal to y, the formula will become sine x plus x equal to sine x cosine x plus cosine x sine x. And x will be added with x, that will be sine 2x. Also, these two terms are also equal to each other. Sine x, cosine x, cosine x, sine x. This will be added and the formula will become sine 2x equal to 2 sine x cosine y. This is the double angle formula for sine function. We can write this formula on another form, which is sine x cosine x equal to sine 2x over 2. If we divide both sides on 2, the formula will be like this: sine x cosine x equal to sine 2x over 2. Here I am going to solve some examples in this formula. The first example is to find sine 120 degree. We can write sine 120 degree as sine 2 multiplied by 60. We can apply the double angle formula. In this part, we can write 2 sine 60 multiplied by cosine 60. We know the values for sine 60 and cosine 60. We can write the value of 60 degree for these two trigonometric ratios. We can write square root 3 over 2 instead of sine 60, and we can write 1 over 2 instead of cosine 60. This 2 will be cancelled with this 2, and the answer will be square root 3 over 2. This was our first example. Our second example is to evaluate sine 22.5 multiplied by cosine 22.5 multiplied by cosine 45. We can use the second form of this formula, which is sine x multiplied by cosine x equal to sine 2x over 2. We can write this part sine 22.5 multiplied by cosine 22.5 as sine 45 over 2. So we will replace sine 45 over 2 instead of sine 22.5 multiplied by cosine 22.5. We can write this as sine 45 over 2 multiplied by cosine 45. Also, sine 45 multiplied by cosine 45, we can write the second form of this formula, and we can write that sine 45 multiplied by cosine 45 as sine 90 over 2. We can replace this part in this question. We can write 1 over 2 multiplied by sine 45 multiplied by cosine 45 as sine 90 over 2. If we multiply 1 over 2 into 1 over 2, that will be 1 over 4 and multiplied by sine 90 degree. We know the value of sine 90 degree is 1. If we multiply 1 over 4 into 1, the answer will be 1 over 4. The second double angle formula is cosine 2x. We know that cosine x plus y is equal to cosine x cosine y minus sine x sine y. If x is equal to y, we can replace x instead of y. So the formula will become cosine x plus x equal to cosine x cosine x minus sine x sine x. These two x's will be added together and we will have cosine 2x. Cosine x will be multiplied into cosine x, and this will be cosine square x. Sine x will be multiplied into sine x, and this will be sine square x. So the double angle formula for cosine function is cosine 2x equal to cosine square x minus sine square x. We can write this formula on two other forms too. So first, we know a trigonometric identity which is cosine square x plus sine square x equal to 1. We can derive cosine square x from this trigonometric identity which is 1 minus sine square x. Also, we can derive sine square x from this trigonometric identity which is sine square x equal to 1 minus cosine square x. So if we replace 1 minus sine square x here instead of cosine square x, or if we replace 1 minus cosine square x instead of sine square x, the formula will be changed into these two forms. If we replace 1 minus cosine square x instead of sine square x, the formula will be cosine 2x equal to 2 cosine square x minus 1. This is the second form of this formula. If we replace 1 minus sine square x instead of cosine square x, the formula will be cosine 2x equal to 1 minus 2 sine square x. So these are the three types of double angle formula for cosine function. Now I'm going to solve some examples in this formula. The first example is simplify this expression 1 minus cosine 2x over 1 plus cosine 2x. We can write 1 minus 2 sine square x instead of cosine 2x, which we had in the third form of the formula. Also, we can write 2 cosine square x minus 1 instead of cosine 2x, which we had in the second form of the formula. So when we simplify this expression, this minus sign will be multiplied in this brackets, and this will be minus 1. If we multiply minus to minus, that will be plus 2 sine square x. Also in the denominator, we will have 1 plus, here we have plus sign, and if we multiply, we will have no changes in this brackets. So here we will have 2 cosine square x minus 1. Here this one will be removed with this one, and this one will be removed with this one. We will have 2 sine square x over 2 cosine square x. These two will be cancelled with each other, and sine square x over cosine square x will be tangent square x. Also, I'm going to solve another example. In this example, we have cosine 11 degree equal to t. Write sine 68 degree in the terms of t. So at first, we can write sine 68 degree is equal to cosine 22 degree, because sine and cosine are co-functions of each other, and if we add 68 with 22, we will have 90. We can replace sine 68 instead of cosine 22, and we can replace cosine 22 instead of sine 68, or in other words, these two are equal to each other. So we can write cosine 22 degree as cosine 2 multiplied by 11, or we can apply the double angle formula on cosine 22. If we apply the double angle formula, we will apply the second form of the double angle formula for cosine function, which is 2 cosine square x minus 1. Here x is 11 degree. So we can write 2 cosine square 11 minus 1. We can replace t instead of cosine of 11 degree. So we can write 2 instead of cosine square t square minus 1. So sine of 68 degree is 2t square minus 1. So this was our today's lesson. Hope you understand, and have a good time. If you have any question, write your comment below. Thank you.